Welcome to Excel and Finance video number 21. Hey, if you want to download this workbook for Chapter 4 or our PDFs for Chapter 4, click on the link below the video and you can download these finance files. Hey, we're in Chapter 4. We're going to come over here to the PDFs and start off here. Introduction to Valuation. Got to talk about the time value of money. In this chapter, Chapter 4, we're just going to look at the basics of lump sum calculations, present value and future value. So, for example, a lump sum just means you put $5,000 in the bank today, which is called the present value, and then in 10 years you want to know what the future value will be worth with all the extra added interest. So, lump sum, we put in one amount and wait, and then later withdraw it. All right, we're going to be talking about the present and the future. So we want to look at a little diagram. The only difference is between the present, if we put $1 in the bank and we wait 1 year, and maybe we have a 10% interest rate, so we get 110. So this is the present right at this moment in time, and this is the future. The only difference is what? It's that bank pays interest. Now, in this example, just a simple example, 10%. Here's the $1 we originally invested, boop, right there. Here's the extra interest that the bank is going to add. So at the end, we have more here in the future than in the present. Now, of course, it doesn't always work that way. When you're making investments, you can lose lots of money. You can lose all your money if you're investing in stocks or even in bonds if the company defaults or whatever. But in general, present moment in time, we invest some money and then later hopefully we make a return. So what is the difference? It's always going to be the return or the interest. Now those are just synonyms. So interest or the word return are synonyms. And later we'll call it the interest rate, a discount rate. Those are all just synonyms, which means similar words to describe the fact that here's a moment in time. Later in the future, hopefully you earn some interest. Present value is called the $1 is called present value. 110 is called future value. Now let's just jump right in here and look at our formula. Now these formulas are different than the book, and they are much more comprehensive. If you use the one in the book, there it is right there. Then when you get to the tricky ones, it maybe is a little bit confusing about the R and the T. This one is explicit. This formula right here will work for every single tricky example they give you. All right, so future value, that's what we hope we have sometime in the future. The present value, that's how much we invest now. Now, in this chapter, our examples are going to stick to like put some money in the bank, right? So I put $100 in the bank. I want this formula to tell me how much it will be worth in the future. So now we need to look at these variables. Future value, oh yeah, future value. Present value, that's going to be the amount that we deposit now to get some future value. Little I is going to be the annual interest rate. It's also called APR. Next chapter, Chapter 5, we'll talk all about interest rates and inflation and all sorts of great things. But little I is, I'm going to use it as my variable for annual interest rate. N is number of compounding periods per year. So if you've ever had a savings account, a lot of savings accounts give you interest every single day. So the number of compounding periods that you earn interest is 365. For consumer loans, usually N is 12 because you have to make a payment every month, and interest is calculated every month. Again, we're talking about pretty much straight investments. Put an amount in, get some amount out in the future in this chapter. And then, of course, number of years, and I'm going to use X for that. Now, this is the period rate. And the textbook just kind of leaves it out. They just give you this R. And then when you get to the hard one where it says, hey, what if you have a savings account that compounds 365 times a year, then you're like, what do I do with this? But this formula is great because the problems will always give you some annual rate. And if there are compounding, which there are not very many in chapter 4, but when they do, at the end of this chapter and then throughout the rest of the textbook, they'll always tell you, here's the number of compounding periods. So to get the period rate, for example, the daily interest rate or the monthly interest rate if you were doing a loan payment or something, it's always annual rate divided by the number of compounding periods. And then also, if you're going to make any calculations, you need to know the total number of periods. Now, if you have a compounding period of 1 and 10 years, then this is 1 times 10. Total periods is 10. But if you have 12 times a year for 12 years, then the total number of periods, meaning the total number of months, is going to be 12 times 10. It's 120. So that's our basic formula. Let's look at an example here. If you put $10,000 in the bank at an annual rate of 6%, compounded monthly for 10 years, how much will you have at maturity? All right, we define our variables. Here's the words. Here's the variables that I'm going to use. Future value, present value. Oh, interest rate, annual interest rate, expressed as a percentage or a decimal. N is number of compounding periods per year, 12, and years, 10. All we got to do is take our formula and plug the numbers in. There's the present value. There's the annual rate, number of compounding periods, years, and number of compounding periods. And then if you're doing it by hand, we follow the order of operations. Zip, do that, and then add that together, and then do the exponent, and then you get your amount. Hey, that's pretty good, right? So I put $10,000 in. I did have to wait 10 years, but I get 18,000. Man, I'm shooting in this in 2010, and the financial crisis has made it real difficult to find a good return. Back in the early 2000s, when I was teaching this class, we could use examples like, 10 or 15%. But at this particular point in history, that would be great. And in large part, 6% would be great because inflation is so low right now. Remember, the point of putting your money in the bank, hopefully, is to get an interest rate greater than inflation. In fact, that's going to be real difficult even in 2010. If you have enough money, you can maybe find some big fat CD at 4 or 5%. But nevertheless, that shows us the math of this calculation. Now, I'm going to, in this class, make you do at least a math or 2 problem like this, meaning I'll have you type a formula in Excel, so we'll learn how to do that. But what are we going to do? We're going to use a function, the future value function. Now, here's like a translator. Here's going to be our future value, present value, period rate, and total periods. That's what the future value function needs. Here's the variables we're going to use for this class, and when we do it by hand, or even when I put my labels in Excel. And here's the arguments that Excel uses. Future value, present value. Oh, the rate, the period rate is always going to be called rate, and total periods is NPER. So when we go over to Excel in just a moment, you have to put the rate, comma, and that's a period rate, comma, NPER. That's just the fancy notation they use for total number of periods. And in chapter 5, we'll use the PMT argument, but not in this chapter. So you put a comma, and then the present value will always be negative. If you want, this translates exactly the variables we're using when you do our math by hand, as you would put them into the function. Here's the numbers, and then here's the answer that we get. Now, very important about these financial functions. This is only the first one we've seen. Future value, we'll see present value, rate, NPER, and a number of other ones. Cash flow matters, and these functions know cash flow. So if you're putting money in the bank, that is a minus. So PV negative because future value understands cash flow. So putting in bank is negative cash flow to you. Now, don't get that confused because it's still your money, but from the point of view of your wallet, you just handed it over to the bank, right? So it's a negative out of your pocket. Later, when we calculate this, it'll show up as a positive. All right. Let's go over to Excel and do our calculation here. Little table here. Here's all of our labels. Here's the variables we're using. Here's the variables that Excel will use. So you could see when we do period rate, it's called rate. NPER. Later we'll see NPERY for total number of periods. I'm even reluctant to put these here. Again, I don't like the textbook because I don't think they're as polite as they should be. If you explicitly say that there's two parts to this, I think that makes it easier to understand. All right, now, in our problem we just looked at, we're going to put $10,000 in the bank. So that's called present value. Present value just means today, what is it worth? Our interest rate is going to be 0.06. Our number of compounding periods per year, 12. Our years are 10. Now I'm going to explicitly calculate the period rate and the total number of periods. Now here's the deal. If they're paying interest 12 times a year, and we'll break this down and look at an example later about how they actually do it, but they're not going to pay you 6% every month. You're going to have to take that annual interest rate, or APR as it's quoted at the bank, and divide it by 12. So that's really what this calculation is about. So equals 6 divided by 12, period rate. Right, and that makes sense. They're not going to give you 6%. They're going to give you 0.005. That's actually 0.5%. If you format that, if you like percents, what happened there? Don't get tricked by formatting. If you increase the decimals, you can see that it's actually 0.5%. Now I'm going to control Z. I'm going to leave it like that. All right, and NPER, hey, there's the years, there's the months. So that's the total number of months. But throughout the rest of this textbook in this class, we'll always have different compounding periods, like bonds for corporations oftentimes are 2 times a year. Sometimes interest is paid quarterly. Sometimes it's paid monthly. Sometimes it's paid 365. All right, so for us, it happens to be months, but the universal label for this is total number of periods. Now let's do our math formula. Now we already did some of these calculations here, so it's going to be pretty easy. Equals present value times, and then open parentheses, 1 plus our period rate. There's the I divided by n. And we'll and then close parentheses, and caret. That is an exponent. And we've already done our x times n. Now notice, the order of operations, this will be done first, which it should. This is called the future value factor right there. Actually, if you highlight this and hit the F9 key, F9 evaluate, you can see that's called the future value factor. We'll actually do that calculation later also. Here we're just seeing our first example. All right, so there's our amount. And let's see how to do it in Excel. Equals FV. And if you read the screen tip here, it explains that this returns the future value of investment, which is exactly what we're doing. I'm going to hit Tab. The rate, we know that that is not the annual rate. It's the period rate, called rate, comma. NPER is not years unless there's one compounding period per year. But for us, total periods, we already calculated it. Comma, payment, we'll do that next chapter, chapter 5, when we talk about loans and things like that. Present value. Now, this is where we're going to have to be careful, because if we put the wrong sign here, then we'll get the wrong answer. This is negative. Always think about your wallet. When I put this in the bank, coming out of my wallet, so it's a negative. And when I hit enter, 18,000. Okay, so those are our math formula and our Excel future value function. Now I want to come over here and type total interest. And what's our calculation for total interest? Simply whatever we got, or n minus begin, as we've done so many times in this class, or whatever the future value is minus the present value. Right? Because this is in the future. We're estimating this. By the way, if this is, a bank account, we have a contract, so it's pretty guaranteed that we're going to get this. So there we are, total interest, the amount we got out after 10 years, and minus the amount we deposited. All right. that's our formula we're going to use. Now we want to step back just a little bit, and we want to talk about what is interest. So I'm going to go over to my PDFs. Interest, oh, it's just like renting a house, except for when you rent a house, the asset is house, and then you give them the money. When you go out and get a loan or loan money to the bank, which is what you're doing when you deposit your savings, you're giving them the asset. You're letting, when you put $100, see, here's our little $100 right here. When you put it into the bank, you're letting the bank use your asset, your $100. So really, we're getting rent on money. Now, when you borrow the money, you pay interest. So when we have a credit card or a home loan or a car loan, we pay interest. But if we have a liability and we're paying interest, someone's on the other side. They have an asset and they're receiving interest. So when you lend money, you receive interest. So in this chapter, we do a lot of savings accounts type of problems. So when we put the money in the bank, forget it. We're actually, most of us don't think of that, but we're lending the money to the bank. So that's why we're going to receive interest. Interest is in dollars. So when we receive our interest, it's in dollars. Unless you're in a different country, then it's in a different currency. Interest rate. We're going to be either given a decimal. Sometimes you can be given a fractional or a percentage terms. So as we already saw, 6% or 0.06. And it means the percentage of the investment or the loan. So if you put $100 in there and the bank promises to pay you 10%, it's $100 times the 10. Similar whether you're earning or paying interest. Now we have to learn about the difference between simple interest and compound interest. All right, simple interest, compound interest, more common that you'll see compound interest, although simple interest contracts do exist. Here it is simple interest. Interest earned on original investment only, paid on original loan. So it could be the investment or the loan. So that just means $100. If you invest $100, they're going to give you an annual interest rate of 10%, but they're not going to compound it. All that means is when they do the calculation, the original the simple interest calculation, $100 times 10%, that's $10. They just slap $10 into your account each year. So there it is. At the end of the first year, it's 110. Then they give you another $10, another 10, another 10. So after 4 years, you have $140. Compound interest, we like this much better. Interest earned on both original investment and interest reinvested from prior periods. So same situation, except for we have compounding interest. $100, 10%. It's only one period per year, but we have 4 years. At the end of year 1, they're going to take 100 and then plus the interest. Notice it's $100 times 0.1. That gives you your 100 plus 10. That's 110. But the second year, they're going to be totally awesome. They're going to say, oh, we'll use the 110 instead of just the original 100. So it'll be the amount in your account plus new interest. And you can see now we get $11, which is just a little bit more. That gives us 121. Same thing this year. They're going to use the 121 times the 10%, and they're going to get now $12.10 instead of 10. They get the total. They use this the next year. So this at the end of the 4th year, they're giving you $13.31 instead of just the 10. The difference between this is interest you're earning on the interest invested. So this is because we reinvested the previous interest payments, and they're paying you interest on that. This is called compounding, this whole process right here, the process of accumulating interest in an investment over time to earn more interest. Let's go over to Excel. So let's calculate. Let's do simple interest for example 2, and then compound interest. Our simple interest is simply, hey, here's the original amount, the principal, times our rate. That's it. So I'm going to say equals this one, because I want to show you the little schedule, and I'm going to hit the F4 key to lock it with both dollar signs. So I'm going to copy this down. Now, year 0, which means when we put it in the bank, how much do we have in the bank? We have $100. Now, at the end of first year, how much do we have? This, notice that's a relative cell reference, one above, plus this, one to my left. Now notice when I copy that, when I enter this, Control Enter, and then copy it down, each year it's going to obey. It's going to get the balance from before, add the new interest. Enter. Balance from before, add the new interest. Balance from before, add the new interest. That's the full schedule. This calculation, however, can be done in one cell, because all it is equals the $100 plus all of the interest. Well, the interest is just $100 times 0.1 times 4. That's it. And you get 140. So that's simple interest. Now let's go look at compound interest. We like compound interest more because we're going to have more in our bank account at the end. Equals that $100 right there. That's the time 0, or year 0 is just when we put the money in. Now, this formula is going to be equals one cell up and one cell to the right, whatever the balance is from over the prior period, times our interest rate right here. Now, when I copy this down, this one needs to be a relative cell reference, but that one needs to be locked. So I'm going to hit F4. All right, I'm going to hit Tab. What is our new balance here? It's equals 1 above plus 1 to the left. Okay, no problem. Now, let's see what happens when we copy this formula down. Now we get 11, and the reason why is because that's a relative cell reference. It's moving as we copy the formula down, and that is locked on our rate. Similarly, when I copy this down, this is just two relative cell references adding. But you can see we got 11, so our new total is 121. When I copy this down to here, $12.10, 133.10. When I copy it down one more, you can see our total amount is going to be 146.41. Now, you can see that each period, it's adding the new interest, right? So for year 3, that's how much was sitting in the account the whole time. So it went to calculate in year 4 the interest. They said, no problem. We'll use that full amount that was in the account times that interest rate. All right, now that's just so we can explicitly see the calculation and the year-by-year addition and how interest is compounded. But we, of course, know that there's a formula for this. Equals, we have our present value times, open parentheses, 1 plus. And now we got to do our period rate. It's always going to be whatever the annual interest rate is divided by number of compounding periods. Now you're saying that's 1. Why'd you have to do it? Well, I always like to do it. If I do it's always going to work. So if I have my input variables, if I change this, it'll work because I did it this way. Close parentheses, and then caret. Now, caret is, as we studied in week 1 when we did chapter 00, that is calculated first in the order of operations. So if we're doing multiplying, and this is multiplication is up in the exponent, you have to put it in parentheses. So years times compounding periods. All right, so that formula will work. 141. And then, of course, we have our future value function. Our rate, again, we're going to have to, if we don't explicitly do our calculation for period rate and total number of periods, then you have to do it in our formula. Interest rate divided by number of compounding periods. So I divided by n, and then comma NPER, years, or x times number of compounding periods, or n. You can see how the screen tip is polite. Comma. We don't use that one until our next chapter. Comma. And the present value. Oh, yes, that has to be negative because it's going into the account. We're depositing it in there. And we should get the same exact answer. Now, let's just compare the simple interest. I'm going to say equals, and I need to get that number from over here. So I'm going to go over to this one right here. Click on that number. Notice up in the formula bar, I can see the name of the sheet. So when I clicked on the sheet, it automatically put the sheet name in it. And now it has B14 because that is B14 on this sheet. Now, hit Enter. It jumps back over to this sheet, and you can see there's 140 bucks. There's the amount for compounding. And the difference is going to be compound minus simple. And we get $6.41 extra. Now let's go look at a chart. I extended this. I did this same example here. We stopped right here, right? But I did it for 10 years. So you can see the difference. In the early years, the difference between simple and compound is not so much. But as time goes on, it gets pretty big. So compounding earns you much more than simple interest. Here's another little chart. This should be somewhat obvious. As your rates increase, right? 0%. Our investments doesn't change at all. 2.5, 5, 7.5. Obviously, here's time, years, future value. This is the amount. So for 20%, it as time goes on, gets bigger and bigger. And that's just another way to see this kind of chart here. But this is when we increase the interest rate. So I think ours was 10% here, 10%. So like this blue one looks like ours. But we can see clearly if we get a higher interest rate, the amounts increase quite a lot there. Now, we still have two more examples of future value calculations before we go on to our next present value calculation. How about this one? If we invest $100K with an annual rate of 7% compounded 12 times a year for 10 years, what is the future value? Now, in this one, I want to be explicit. I want to do the period rate, total periods, and even the present value factor here. So we'll calculate our period rate. They're giving us 7% annual, but it's compounded 12 times per year. So that is the monthly rate, 0.0058333. All right, total periods. Well, we have our years times our number of compounding periods. Now, does it matter what order I do? No, it doesn't. 2 times 1 is the same as 1 times 2. And let's do our future value factor. Now, before calculators and the proliferation of handheld calculators and then Excel, there actually used to be tables you used for this. But here, and this table would have these numbers in there. I'm going to say 1 plus, and I have my period rate, caret, and now I just have to click on that because I've done the calculation in a separate cell. See, it's much easier if you do your calculations explicitly in the cell. Then you can see them on the face of the spreadsheet. And this formula is much easier than that one we just did a little bit ago. That is our future value factor. The way you use these, and actually you'd never use these in real spreadsheets, but I'll just show you anyway. You take that times your present value. And that gives you your future value. All together, present value times open parentheses 1 plus this rate, caret that. And finally, future value. Our rate, you got to be always sure it's not the annual rate, it's the period rate. All of these have to be in agreement. So if it is a monthly rate, then you have to have monthly rate there. And then total months, comma. We're not using that one. And present value is just a lump sum, so we say minus that right there. Total interest earned on this particular investment, whichever one of these, I'm going to take that one, minus our original amount invested. And then in this class, we are going to, on tests and quiz, you have to write it out explicitly. And so all I've done here is said, if we invest 100K with an annual rate of 10% compounded 12 times per year for 10 years, our future value of the investment will be of that amount. 100K plus some change is the interest earned on the investment. All right, one more. I'm just going to skip to the chase here. Future value, I'm going to just do it at one calculation, but let's read. If we invest $15,000 with an annual rate of 5.5 compounded 365 times a year for 10 years, what is the future value of an investment? Again, a lot of our oftentimes your savings or checking account or some sort of minimal interest earning accounts at your banks will calculate interest 365 times a year. So equals FV, the rate. I did not calculate my period rate, so I'm going to say that divided by 365, comma, NPER, years times periods, comma, no PMT, comma, and then minus present value. That's just a negative cash flow into the bank. And our interest earned is going to be this. And then in words, we write, if we invest 15K at an annual rate of 5.5 compounded 365 times a year for 10 years, our future value investment will be 25K 997.72. Of that amount, 10,000 and some change is the interest earned on the investment. All right, when we come back in our next video, we'll talk about present value. And then we have a couple more videos calculating the interest rate or calculating the total number of periods. All right, see you next video.